The temperature at the bottom of a 40-meter deep lake is 12 degrees Celsius. Okay, so we're done with this one. Let's do the next one now. So question 3 reads, the temperature at the bottom of the 40-meter deep lake is 12 degrees Celsius, and at the surface it is 35 degrees Celsius. An air bubble of volume, 2 cubic centimeters. Okay, so let's just write out the information given. So temperature 1, this is question 3, by the way, in case you're joining us. So temperature 1 is given as 12 degrees Celsius. So we're supposed to convert this to kelvins, of course. So we're just supposed to add the 2, aggregate to 85 kelvins, like that. Then from there, we have another temperature, which is 35, so we'll have to do the same. So temperature 2 is 35 degrees Celsius. Again, we convert it to kelvins by adding 273, and we'll get 308 kelvins. Then we've been given volume 1, which is 2 cubic centimeters, and we're looking for volume 2 in this case. Okay. So let us just go through the question from the beginning. Question 3. It says the temperature at the bottom of the 40-meter deep lake is 12 degrees Celsius. At the surface, it is 35. So you have your lake. We're saying that at the bottom here, the temperature is 12. At the top, at the surface there, it is 35. So a bubble of 2 cubic centimeters rises from the bottom to the top. So it rises and has a volume of this. Now want to find the other volume. Now, let's talk about pressure now. So in the question, you've been told that atmospheric pressure is equal to 10 meters of water, meaning that pressure 1, in this case, pressure 1 will be equals to 10 plus 40. Why are we saying 10 plus 40? Because if you go through the question, it says, the first statement, it says the temperature at the bottom is 40. So the temperature at the bottom plus the atmospheric pressure, hence we'll have 50, pressure of 50 of water, atmospheric pressure of water. So remember, P1, we said is 10 meters, that's what we said. So now, with this information, we can go ahead and calculate the volume. So we're going to use the mixed gas equation, which is pressure 2, or we can start with pressure 1. Pressure 1 times volume 1 divided by temperature 1 is equals to pressure 2, volume 2, temperature 2, like that. So we are looking for volume 2. So remember, if we try to break it down from what we have here, we're looking for volume 2, we have volume 1 already, which is that. Okay. So let's make volume 2 the subject of the formula by cross multiplying. Hence, we'll have P2 V2 T1. This is equals to P1 V1 T2. We just cross multiplied. Then after cross multiplying now, we can make V2 the subject. So V2 is equals to P1 V1 T2 divided by P2 T1. That's what we get. Okay. So now, based on the information that we have in the question, let's just go ahead and do the substitutions. This is supposed to be pressure 2. So substituting, this is what we're going to get. We know that V2 in this case will be equals to pressure 1, we have 50. Volume 1, we have 2. So volume 1, we have the 2. Temperature 2, where is temperature 2? Temperature 2 is 308. We have to use kelvins, not degrees. Divided by pressure 2 is 10, and temperature 1 is 285. Okay, so let's go ahead and compute that. Let's see what we get. Okay, so after computation, I have found 10.81. So 10.81 cubic centimeters. I hope we have the same value as well. Okay, so let's move on. That was question 3, I believe. Let's move on. Let's look at question 4. I hope we have the questions, by the way. So question 4 reads, a uniform glass tube of length 100 centimeters is to be filled with mercury. So let's remove this. A uniform glass tube of length 100 centimeters is to be filled with mercury so that the volume of the tube occupied by mercury appears to be the same at all temperatures. If the volume of expansion coefficients of the glass and mercury are, okay, so this is what we have. We have been given 2.6, this is question 4, by the way. We've been given 2.6 times 10 to the power negative 5, that is a degree Celsius. Also, we've been given 1.82 times 10 to the power negative 4, that is per degree Celsius as well. Right. Okay. Now let's understand what these two mean. What are these values? So if the volume expansion coefficients of glass and mercury, so this here is for the glass, this for the glass, and this is for the mercury. Okay. These are the volume expansions for the two. Okay. Now let's break it down. We'll see what happens. So it's important to note that this will be given by the expression, the change in volume. Change in volume is equals to gamma volume 1 and the change in temperature, like that. Now remember, which volume changes are we talking about? We're talking about the volume change for the glass and the volume change for the mercury. Since the statement, the question, there's a statement in the question which says, they appear to be the same at all temperatures. This simply means that the change in volume of the glass is equals to the change in volume of mercury. Let's just use the symbol for mercury, which is Hg. Okay. So now we have two equations, and we'll see how we can combine them. Let's call this equation 1, and let's call this equation 2. Like that. Okay. So now, from equation 1, let's see how we can use it to make substitutions. Okay, so now let's combine the two. So the change in volume of the glass is equal to the change in volume of mercury. So using this expression, remember, this represents the change in volume. Now, this is just in general. So what we want to do is, want to use this to substitute here where there's glass and substitute here where there's mercury. So this is how we're going to work out. We can say the same formula, which is gamma. Now, this is gamma for the glass, volume for the glass as well, change in temperature is equals to, when you come to mercury this side, where there's change in volume for mercury, we can use the same formula again. So that is gamma, that is for mercury, Hg. Again, volume, so that's the volume for mercury. And then we're multiplying with the change in temperature. Okay, so that's what we have for now. So from there now, how do we proceed from here? So first of all, we can simply say, we know that volume, something you need to know, something you need to remember, volume, V, is equals to area multiplied by a certain length. Volume is equals to area times length. Okay, so now that we know that, then we can say the volume of glass is equals to the length of the glass times the surface area. So that's what we want to substitute everything with. Now we can clearly see that on both ends we have the change in temperature. So dividing both sides by the change in temperature, the change in temperature will just cancel out. So volume of glass, we're going to say gamma for the glass. The volume of glass is given by area multiplied by the length of the same glass we're talking about. Okay, so we do it like this. This is equals to gamma for mercury. The volume for mercury, we're going to substitute it with surface area multiplied by the length of that particular mercury, like that. Okay, I hope we're following it. Then now, how do we proceed from there? Remember, what we're looking for from the beginning of the question, we're looking at the length of mercury, of the column of mercury, meaning that the length of the column for mercury is this one. This is the length of the glass, this is the length of the mercury, okay? So now, if you go back to what is given in the question, we can clearly see that we can divide both sides by the area. Area can cancel out as well, because everything is just multiplying. So if we divide both sides by the area, which is A naught, divided by A naught, the area will cancel because everything is just multiplying. So what do we remain with here? We remain with the gamma for the glass as well as the length for the glass. Here we remain with gamma for the mercury and the length of the mercury. By the way, what is this gamma? If you go in this question, if you go back to the question, this is the volume of expansion of the coefficients. So since we're looking for the value of the length of mercury, let's make it a subject of the formula by dividing both sides by gamma of mercury. So what we say, length of mercury is equals to the product of these two. So that is gamma of the glass multiplied by length of the glass divided by gamma of mercury. Now, what is gamma of the glass? Gamma of the glass has been given this one here, which is 2.6. So 2.6 times 10 to the power -5. Multiplied by length of the glass. It's given in the questions, given as a 100 centimeters. So since it's 100 centimeters, it's fine, we can use it as a centimeter. So we can use 100 divided by gamma of mercury. Gamma of mercury is 1.28, or 1.8 rather, times 10 to the power -4. Okay. So remember that we didn't change the units for the length of the glass, meaning that our units for the length of mercury will also be in centimeters. So if we do the computation, what we're going to get is simply 14.3. So the length of the mercury glass is, or the mercury rather, 14.3. We left it in centimeters. If you change this to meters, then your answer there will also be meters. Okay, I hope that's okay.